What's up? The Cabinet Vision guy here for my second video podcast. So, I was browsing around the Vero eSupport site when I came across this post. I thought it might be fun to try and do something like this, so I gave it a whirl and came up with this object. What we have here is a stack of shelves that I can resize to meet just about any needs that I have. On top of that, I get a proper cut list and some nice renderings from it. But enough about that. Let's see what it took to make this. First, let's go to the face ortho viewport so we can see all the parts that make up this piece. If I start clicking on the parts, you can see that they are all contained inside of another object called the liquor shelf. Now, this is my favorite part of Cabinet Vision. Yes, the user-created standards have far-reaching power and the wizards and catalogs are cool, but this ability to stack objects inside of objects that are inside of objects that are inside of objects and so on is what makes it really powerful to me. You see, I only had to build this liquor shelf once. Then I just placed it as many times as I needed inside of another object. I can create all kinds of compound intelligence for my objects this way, and best of all, I can then save them back into my library so I don't have to do it all over again. So let's go ahead and get out of this and find that shelf that I made and store it in my library. Now, this is a much simpler object, or at least it seems to be, as it's just one of those shelves. What we have here, though, is a series of parts that I have added intelligence to for placement, size, and some additional parameters. If we switch over to the reports viewport, we can see all the parts that I actually have. Not really a lot in the grand scheme of things. So let's switch back to the face ortho viewport and click on one of the parts. I want to look at the face panel here to start with, so I will click on it and select the panel. Next, I want to right-click on the part and select Properties, then click on the Parameters tab. All the parameters that have this little person image next to it is a parameter that I have edited. You can see that most of them also have the type set to equation. Now, instead of looking through all these equations, I think we should just go ahead and build this object again so that you can see the equations in action. We'll start by pulling out the empty base object onto the wall and going to its face ortho viewport. Before we go any further, we need to plan out what we want to do. Since I already made this object once before, I already know what I want to do. I need to be able to control the end inset for each end, as well as the inset for the face. This will require me to make some new parameters, so let's open the object tree to do that. Each of the parameters we will make will be an attribute, because I want to be able to edit it from the sidebar. Next, I want to create a name for the parameter. It's important that I create a name that I can easily remember. I like to start custom parameter names with an underscore and finish it off with a name that represents an approximation of what the parameter does. So let's call this one underscore face inset. Next, we need to set the description of the parameter, which will be how it appears in the sidebar. So let's call this face inset. Finally, we can just set a default value. I will use 1 and click OK. Now we just need to do the same for the left and right inset. With those three parameters, I have more control over the shelf than I normally would when building an object from scratch. The next part of our planning is how to actually build the piece. Typically, you would start with the substrate and build outwards. Well, for this, we want to build from the outside in. I want to have a skin for the left and right sides, as well as a skin on the top. And I want to have a nosing around the perimeter of the shelf, so we're going to start with those items first. To get things started, we'll just click on the New Part button here in the sidebar. This brought up our New Part dialog. This is one of the most important steps of adding new parts, as the part we select will determine what materials CV will use for the part. We can, however, change it to suit our needs, but I would rather just let things stay automatic. So I want to create a top skin. Well, there isn't a skin top part, so I will just use the same part as the skin left finished end. At this point, I would typically stop what I'm doing, go to the part catalog, and create my own new part. Unfortunately, that's a lot of work for this right now, as I would have to go to my material schedules and make sure that each schedule has a material assigned for the part. So yeah, just going to use the skin left finished end. I will, however, rename this part for my guys in the shop to know where it goes. Everything else I want to leave the same, so I can just click Next. Now we get to the size portion. This is entirely arbitrary, and since we're going to adjust the sizes using formulas, we will just leave this alone and click Next. Now we get the orientation. Since we want this to be the top skin, we will set it to top. I don't need to change it because we can just rotate the part around in the viewports, but this makes it easier to start with, just setting it to the correct orientation. Since we don't want to change any of the finishes, we can just click the Finish button. And now we have our part. But it's not in the right place, nor is it the right size. It is, however, selected. So we can just click on the values in the sidebar and change them to suit our needs. The first thing I want to change is the X location. I don't really want it to be 0 on the final product, but for now that works just fine. The up and down, though, needs to have an equation, as I always want it to be at the top of the object. So I will click on this little ellipsis button, select equation, and change the then to the following: cab.dy minus underscore m colon dz. Now let's stop and take a moment to talk about what I just did. The equation is essentially an if-then statement. It's saying if 1, then cab.dy minus underscore m colon dz. The if statement will always return true because 1 is, well, 1. The then statement, cab.dy minus underscore m colon dz, is the difference of the cabinet height, or cab.dy, minus the thickness of the material, which is what underscore m colon dz means. Both of these values are what we call system parameters. This means that Cabinet Vision will always know how to handle these without any prior settings or values. If I click the test button, it gives me the value of 23 3/4 of an inch, because the thickness of the skin is set to 1/4 inch, as per my materials. Now we can just click OK to see the part move into place. But why did I want the part to be at the top minus the thickness of the material? Why didn't I just set the height as a fixed number? Well, that's because I may want to resize the object later, and this way I don't have to change the part. I can just change the height in the floor plan or elevation viewports, or even an order entry, and the part will be where it's supposed to be. Also, we didn't set it to be lowered by a fixed amount because I may change my material at a later date, and the equation I use will compensate for that. While our part is in the correct location, it's not correctly sized. So first I'm going to go to the Plan Ortho viewport, click on the part, and change the dx and dy values for this part. Now I'm throwing around a whole lot of letters here, x, y, dy, dx. There are a whole lot more, rest assured. But what do they all mean? Well, if you watched my first video, you would have heard me call CV a 3D engineering software, and as such, I need to specify the 3D location of the part. Those are the X, Y, and Z parameters of the part's origin point. Whenever you are setting the location of a part, it is always relative to this specific point, and all parts have one of these points. What about the dx, dy, and dz? Well, those are sizing parameters. I like to call them distance parameters. For instance, dx is the distance along the x-axis, which means that dy is the distance along the y-axis, and so on and so forth. Again, all of these values are relative to the origin point, and there are a few more, but for right now, these are all that we need to worry about. So back to sizing our part. First, I'm going to change the length, or dy, of the part. So I'll just click on this ellipsis button and change it from value to equation, and set the equation to cab.dx. This ensures that the part will always be as long as the object is wide. Now, just like the X position, this isn't the final length we want, but we will adjust it later when we can. Finally, I need to set the width, or dx, to be the same as the depth of the object. So I click on this ellipsis button and make the equation cab.dz. And now you can see we have a semi-properly located part that is almost the right size. Now I want to add my shelf part of this object. So I just go to the Add New Part and select Shelf, and all the other values will remain the same, so I can just click Next until I can click on the Finish button. Now that I have my part, I want to locate and size it as well, so we'll start with the X location. I will set the parameter to an equation, and set my equation... Wait, my skin is set to 0. Why didn't I just set this to 0? In fact, why did I use this equation, and what does it mean? Well, because I like to be lazy, and I told you that our skin isn't in the right location, I just told it to use the X location of the skin, because our shelf's not going to be in the right location as well if I use 0. But I didn't tell it to use any skin, but specifically the first one that it finds in the object tree. Let's go ahead and fill out the other variables in a similar fashion, and then we can look at the object tree to see what I mean. So the y needs to be cab.slf at 1.y minus underscore m colon dz, which is telling CV to place the part at the same y value as the skin and pull it down by the shelf's material thickness. Again, so I don't have to change anything if the material changes. Then I need to set the dy as the same as the skins, and finally the dx the same as the skins, dx. Okay, so if I look at this in the face ortho viewport, we can see that it's properly placed. Well, it's as properly placed as it needs to be right now anyways. So let's take a look at our object tree so I can explain those equations a bit better. When the object tree opens up, we see the object. At this time it's called empty base object, because that's what we're using. If we expand that out, we can see our parts for the shelf. The parts are ordered as they are placed in the object. You see the skin top, or SLF part. By the way, the name of the part that can be used in equations will always be the one contained in the parentheses. So, if you remember, we set the x of the shelf to cab.slf at 1.x. To break that down, we start with the cab object, which is the parent. Then we tell it to look for an SLF part. This @ symbol tells CV that there may or may not be more than one of these parts, and I need to use the one that I give the index number for, which is this number directly after the @ symbol. Once CV finds that part, it then needs to grab the x value. We did pretty much the same thing with the y, dx, and dy values for the shelf. Now that we know what all of that means, let's close out of the object tree and start adding some more parts. The next part I want to add is the outside skin for the left end. So I'll add another skin left finished end part, set the orientation to left, and click OK. If you remember, I created 3 variables to control the inset for the left and right ends as well as the face. So the x position of this part needs to be the same value as the left inset value with an additional amount for the material thickness, which makes it cab._left inset plus _m colon dz. Now, I could make the equation _left inset and CV would look up through the object tree to find it, but I like to be exact for these kind of things. If I click OK, you can see the part snap right to the 1-inch inset that we specified. Now let's finish this up by setting the other sizing values. I'm going to set the length, or dy, to the y position of the shelf that I added. The reason for this is that I want the skin to always fill the void from the bottom of the object to the bottom of the shelf, and making sure that its length is set to the shelf's y value will ensure that happens. Finally, I'm going to set the width, or dx of the part, to the depth of the object, so that's just cab.dz. Now we're starting to get somewhere with this thing. If we take it to the 3D viewport, we can see how well it's coming along. But we aren't quite done yet. Actually, we're nowhere near done. So let's go back to the face ortho viewport to add a left sub-end. I'm adding a sub-end because that's what I want to add. You can use any left end part, like a left finished end or a left unfinished end or whatever, as long as it's a left end part. Now I want to match the sizing of the left skin, so we will just do that real quick. The x should be cab.slf at 2.x plus _m colon dz. Now you see, instead of having the 1, we have 2. This will make sure that the left sub-end will find the second left skin to grab the x location from. Basically meaning that it's not going to use the top skin part. Next, the dy should be the same as the left skins, and the dx should be the same as the left skin as well. Awesome sauce. We have our left sub-end now. I'm going to really quickly do the same for the right end and skin. The only difference will be the x locations of the skin, which will be cab.dx minus _right inset minus _m colon dz, meaning that it will move the skin all the way to the right, pull it to the left by the amount of the right inset value, and just a little more for the skin material thickness. As well, the right sub-end will have the following equation: cab.srf at 1.x minus _m colon dz, which will match the right skin's x position and pull it back for the thickness of the sub-end. So now we have our left and right parts, but experience has taught me that the right parts aren't exactly correct yet. We can see this by looking at the end ortho viewport. See, our right parts are sitting behind our object. Why is this? Well, it's because of that little origin point. When I was creating these parts, I told them to have a right orientation, and that placed the origin point here. Now, how can we fix this? We could use another equation, and I will do that, but I want to add my face parts first, and you'll see why in just a second. So we will move to the face ortho viewport and add a new skin. Once again, I will use the skin left finished end for this. The X location will be the left inset value. Next we need to set the length of the part, which will be the same as the shelf's Y location, as is the same as other parts. The Z location will be the depth of the cabinet, minus the face inset value, minus the thickness of the skin's material, which makes the equation cab.dz minus cab._face inset minus _m:/dz. Now, we haven't worked with the Z location yet, but this is the first of several times that we will. What we are setting here is the part's origin point's distance from the back of the object. And finally, we get to set the width of the part. I want it to be the width of the object minus the left inset value and minus the right inset value. So that equation is cab.dx minus cab._left inset minus cab._right inset. And now we have our face skin set. If we move back to the side ortho viewport, we can see that not only is our right end not placed correctly, but our left end parts now intersect our face skin. To correct this, we need to fix the width of the skin, and we may even need to fix the width of the left sub-end. Before we do that though, we need to figure out how we want the left end and the face panel to join. In this diagram, we can see the options that we're going to go over. We can either have the end go to the face inset value and have the face panel butt into the end, or we can have the opposite and have the face panel go to the left inset value and have the end butt into the face panel. I prefer option B, so that's what we're going to cover now. If you remember, our left sub-end is the same size as our skin part, so all we have to do is resize our left skin and the sub-end will take care of itself. So I will click on the skin and change the dx of the part to cab.dz minus _face inset minus cab.slf at 3._m:/dz. Now don't forget, since this is the third left finished skin, we need to use that @3 identifier to let CV know which one to use. And now we can just click OK to see the left skin and end properly place themselves. Now let's correct the parts on the right side of the object. First I'm going to click on the skin and change the dx to the same value as I did for the left skin. So that's cab.dz minus cab._face inset minus cab.slf at 3._m:/dz. Next I want to change the z value so that it lines up with my other parts. I'm just going to set this as dx. This tells CV to use the part's dx, or width, value as the distance of the origin point for the back of the object to the origin point of the part. Now, we can see that I forgot to link the right sub-end to the right skin, so let me fix that real quick. Now we're getting to the home stretch. Just a few more parts and this object is done. The face panel that sits behind the face skin is what I want to add next. I want to set the X position as the same as the left sub-end. So that's cab.s_lse at 1.x. Next, I want to set the height of the part, or its dy, to cab.sh at 1.y, as I have done with all the other parts below the shelf. The width, or dx, is a little different than all the others. Instead of using the cabinet width, I want the panel to be the distance between the left and right sub-ends. So the equation that I can use would be cab.s_rsc at 1.x minus cab.s_lse at 1.x. This tells CV to make the part as wide as the x value for the right sub-end, and then subtract the x value of the left sub-end. This makes sure that the panel is always as wide as it needs to be to fill that void between the two ends. And finally, we just need to set the z value for this. So we can set that as cab.slf at 3.x minus _m:/dz, which moves the back of the skin, which moves it up to the back of the skin and backs it off by the thickness of that panel material. And there we go. Now we have a nice little face panel right there. Now let's add our shelf nosing. For this, I want to use the shelf bullnose part. So our first move is to set its X position. That's going to be simple, as it only needs to be the thickness of the part, so _m:/dz. Next we want to set the dy. I want this to cover the skin as well as the shelf, So I will set this to cab.slf at 1 ._ m dz colon dz plus cab.sh at 1 ._ m colon dz. Next, we want to set the distance of this part from the top of the cabinet, or object. This time I'm going to use the cab.dy minus dy. This tells CV to place the part at the top of the cabinet, then bring it down by the length, or dy, of the part. Now we just set the length of the part to the depth of the cabinet, or cab.dz. And there we go. Since I'm pretty sure that you have gotten the equations for now, I'm just going to go ahead and zip forward and place the final two bullnose parts without all the explanations. If you remember, when we first started making this object, I said that our top skin and shelf are the wrong size. Now that we have the bullnose added, we can see exactly why it's wrong. They're kind of intersecting into our bullnose parts. So to correct this, we just need to change the x, dx, and dy parameters of the top skin part. I'm going to move to the plan ortho viewport to do this, so I'll click on the top skin and start editing. The x needs to be the same x value as the left bullnose part, so that's cab.s_shbn at 1.x. Next, we set the dy of the part to cab.s_shbn at 3.x minus cab.s_shbn at 1.x. We've used similar equations to fill space between two parts, so we're just going to do that again here. And finally, the dx. Instead of changing the whole equation, we will just remove the front bullnose thickness from what's already there, so that's cab.dz minus cab.s_shbn at 2._m colon dz. And there we go. The main parts of this object are totally finished. If we take it to the 3D view, we can see exactly what it looks like. Perfect. Now, if we go to the room's elevation viewport, we can see that we have the ability to stretch the object around, just like any other object, and our parts will follow the logic that we gave them. Now, for me, this isn't totally done. I don't really have enough control over it. I'm going to go ahead and pull my liquor shelf out of the catalog that I've completed, and show you what I mean by that. You can immediately see that I have more than 3 parameters here. Let's go to the assembly level so that I can explain what these different parameters do. First, we have the use vertical skins parameter, which I can set to true or false. True makes the left, right, and face skins appear in our views and cut lists, while false removes them. Then, of course, I made one for the horizontal skin, the one here on top that we used for the shelf. Next, I gave this ability to control the top scribe value for the shelf lips. If I set it to 1, you can see that the lip parts increase in width and the shelf and skin drop down to give me the proper scribe value. And since I had a top scribe, I figured it would be good to add a bottom scribe, so that's there. Changing this will increase the height of the shelf lip parts and push them down. This max width single parameter allows me to specify a maximum object width. When the parent object equals or exceeds this number, a partition part is added beneath the shelf, in the middle of it, to make it more stable. And finally, I have this mating adjustment value. All this does is make the vertical parts, like the ends and skins, increase in height and drop down below the object. You know about the other parameters there, so why have all of these? Well, if I make an object and pass it out to my designers, I don't want them mucking around in the object tree or with part parameters, so I give them an option to change things like this. The big question that I would ask if I were a designer and I hadn't made this is, what's this mating adjustment for? Why have it? Well, let's make another new object to check out why I put it there. First, I want to go back to the room's elevation view. Then I want to delete this object we've been working on here. Next, we need to add an empty object. Once it's there, we'll just make it 48 inches wide so I have some space to work with. Now we can go into the object's face ortho viewport and start working. Up until now we've been adding parts, but we don't want to do any parts or add any parts. So, well, we actually do, but not the way we've been doing it. Now we want to add our object. So I will click on that button, find my liquor shelf, and place it in the object. I want some basic logic to be placed here, so I will set the x to 0 as well as the y, which will place the object in the lower left of the object. And then I'm going to set the height as 1/2 the object's height. So that would be cab.dy/2. Now what's the deal with the colon in front of the equation? This tells CV to look at the parent object. If I were to set it to cab.dy/2, CV would look for the first cab object in the tree, which would be the liquor shelf, and that would just be wrong. So now I want to set the width, or dx of the object, to cab.dx, and the dz to cab.dz. This will keep the shelf as wide as the object, as well as keeping it as deep as the object. Now, just for the purposes of showing off this mating adjustment, we're going to set the shelf lip, the top scribe on the shelf lip, to 1 inch. And now we can add our next object. I will inset this by about 4 inches all around. So the x will be 4, the y will actually be set to cab.dy divided by 2, so that it's the same height. So it's set at the same height as the bottom shelf is tall. The height will be set as the same as the bottom one, which will be cab.dy divided by 2. And the width will be cab.dx minus 8 for the 4-inch inset on both sides. And the dz will also be cab.dz minus 4 for the 4-inch face inset. Everything looks good for now, so let's take it to the 3D viewport. Still looking good, but if we look closely, in fact, let me render this to make it easier to see. We can see that my top shelf is floating above my bottom shelf, and I really don't want that. So now if we go back and set this mating adjustment to 1, that's no longer the case. So that's pretty much it. On top of the added parameters, I actually created a couple of new parts in my part catalog. The skin top finished and skin face finished. The logic is a bit different as well. Not just changing the names for the parts. For instance, where we set the skin left finished for our top skin to have a y of cab.dy minus underscore m colon dz, I used cab.dy minus dz. The reason for this was that I wanted to have a way to easily remove my skin with the use horizontal skin parameter, but I still wanted to link my shelf part to the Y location of the top skin. This let me do that, as I just changed the DZ of the top skin based on whether that flag was checked or not. As is usual, I will be passing this object as well as any parts that go along with it to you. Just check my Facebook notes on how to get it. Now, to finish this video up, I want to say that this isn't the only way to do this. There may be many ways to do this, and I would love to hear about how you would accomplish something like this. So please, let me know by posting it on my Facebook wall, my Google Plus wall, or through an email. I may recreate your way of doing it and show it in a future video as well. Before we finish up, I'd like to thank the Hayfla Company for their continued support, without which this podcast wouldn't be possible. As always, or perhaps I should rather say, as has been done so far, here's another quote from the list of my favorite sci-fi authors.